This is Algebra 2 with Trig, Chapter 14.2. We're going to translate and reflect trigonometric ratios. This is for day 2, mainly focusing on reflections. If we look here at our graph, we're noticing that the sine graph, which would typically be 0, 1, 0, negative 1, 0, when you throw the negative in front, it flips it upside down. It reflects it over the x-axis. That's a reflection. Even with the cosine, which typically is 1, 0, negative 1, 0, 1, when you throw the negative in front, the a value is negative. It now starts out at negative 1 and builds up and then back down. So that's a reflection over the x-axis. They're reflections of the original graph of sine of theta and cosine of theta. That's just like saying sine of x and cosine of x. When we graph, we're going to notice that our a value is negative. So that means we're going to have a reflection. We're going to reflect each point, and then we're going to stretch. If it has an a value other than 1, it could shrink if the a value is less than 1, and then we would translate. So we could have up to 4 graphs. We'll have our parent function, and our parent function will be sine b of x or cosine b of x. Then we'll throw on the reflection, the stretching, and the translations. So for example number 1, negative cosine 4x plus 1. We notice that the a value is negative 1. That's going to make the amplitude 1. The amplitude is always a positive value. It's the absolute value of a. It's a length, it's a distance from the midline to the maximum point, or midline to the minimum point. That's the same amount. So that distance in this case will be 1. The b value is 4. There's no parentheses, so there's no h value, and the k is going to be your last term. The midline is going to be y equals k. In this case, we're going to call it y equals 1. To calculate the period is 2 pi divided by b. So 2 pi divided by b, our b value is 4. So the period is going to be pi over 2. So if we were to put this graph right alongside y equals cosine of x, y equals cosine of x would be much longer, be 4 times bigger. Now we're going to calculate what the increment is. The increment is period divided by 4. So to calculate that, we're going to take pi over 2 and divide that by 4. You can consider that 4 over 1. And we'll multiply by the reciprocal to get pi over 8. So that's our increment. What an increment means is that's how the x values are going to change as we build our graph. We also use the increments on our table. We're going to be graphing y equals the cosine of 4x. We're going to start out with that basic parent function. So we always start out at 0, and then pi over 8. Then you could say 2 pi over 8, 3 pi over 8, and 4 pi over 8. You could simplify those as you write them down if you wish. Or you could wait to simplify them when you put them here on your graph. So pi over 8, pi over 4, 3 pi over 8, and then pi over 2. Notice how the last one is going to match what the period is. This simplifies to pi over 2, so the period is going to finish at pi over 2. So without any reflections or any translations, our y values for cosine would be 1, 0, -1, 0, 1. So thinking about what our scale should be, by going 2 steps at a time should give us plenty of room to reflect and do a small translation. So the cosine graph, this parent function, come right through. That would be y equals the cosine of 4x. The 4, the only thing that's showing up here with the 4 is that the scale of the x is different. That's the only thing that changes. From all these graphs, they most all look very similar to this. The only thing that might be different is the scale value. And then if you translate different amounts or stretch it at different amounts. This graph doesn't have a stretch, but it does have a reflection. We do reflections first anyway. We're going to take all of our y values and multiply those by -1. If you would want to write negative cosine of 4x, that would give you -1, 0, +1, 0, and -1. You could build that table on. That helps you organize to know where you're putting your values. So now we have y equals negative cosine of 4x. Since there's no stretch, because there's no value other than the -1, we're going to translate this 2 units, or actually just our k value is 1, so 1 unit up. We take each one of these and go up 1. So that's going to give us this midline right here, and we want to label that y equals 1. This graph is negative cosine of 4x plus 1. Our next graph has an a value of -3. So that means the amplitude is +3. Amplitude is always a positive number. The b value is a value that's with the x, so that's a half. H, there's no parentheses here, so h is still 0, and the k value is 2. Since the k value is 2, we know our midline is going to be 2. We're going to calculate the period, and the period is 2 pi divided by b. So that's going to be 2 pi divided by a half. So what happens when you have a fraction with a fraction? We multiply by the reciprocal. So that's going to give us 4 pi. So now, instead of graphing over a period of 2 pi, we're going to stretch this out. It's going to really grow and become 4 pi. You won't see a huge difference on the graph except for the scale on the x-axis. The increments. The increments should be calculated using period divided by 4. So 4 pi divided by 4 gives us just 4. The 4 is crossed out, gives us just pi. So if pi is the period divided by 4, that gives us our increments. Our increments are pi, so we have 1 pi, 2 pi, 3 pi, and 4 pi. Notice this last box is the same as the period. So you can go to your graph and you can label what your x-axis is using your increments that we calculated. We're working with the graph, the equation, sine of half x. So anytime you use sine, before we do any reflections or stretches, sine is 0 at 0. At the first critical point, we're up to 1, 0, -1, and back to 0 again. For this graph to work, we're going to have to go by a scale of 1. Each line's got to represent 1. I'm noticing this because we're going to have to stretch by 3, and then we're going to even have more translations to do. So I've got to condense this as small as we can. So the sine graph rolls up. So y equals sine of half x. The graph looks small, especially when we change the scale and don't make it go up as high. But in reality, we're going all the way out here to 4 pi. We're going twice as far as normal. On the previous graph, we only went to half pi. We did the whole cosine all within this area. So this is really stretching out. So from here, we look at if we have any reflections. So y equals negative sine half x is going to leave us a 0, then a -1, 0, +1, and 0. So we're going to come down here and build ourselves back up. So y equals negative sine of half x. From this point, we're going to look at a stretch. We have a 3 for an a value, an amplitude of 3. So that means instead of going down 3, we're going to go to, or going down 1, we're going to go down 3 times that. And we'll go up 3 times that. The 0 will not be affected. So this is the graph y equals -3 sine of half x. Then with that graph, what we have left is our translation. We're going to slide this graph 2 units up. So we're going to take every one of these and go up 2 units. Each of these critical points climbs up 2 units. So we'll roll through each one of these points with a midline that cuts right through at y equals 2. Be sure to label your midline, label your graphs. In this case, -3 sine of half x plus 2. On the next page, we're looking at y equals negative sine of x plus pi over 2 plus 3. Notice the pi over 2 is in parentheses. Our a value is negative 2, so that makes our amplitude 2. The b value is the value that's between the sine and the x. We don't have any, so that would just be 1. We know that the h value is negative pi over 2. The way we know this is negative pi over 2 is our typical equation for sine is a sine b x minus h plus k. The b value is always outside the parentheses, but the x minus h, the formula is minus. So if it's a positive, then we knew that a negative and a negative made that positive. So the h had to be negative to help produce the positive pi over 2 in our equation. Our k value is 3, so we know our midline will eventually end up at 3. For us to calculate the period, we're going to start with 2 pi divided by b. So 2 pi divided by 1 is just 2 pi. So we know the increment is going to be 2 pi divided by 4, which is pi over 2. That's our standard scale. So we'll be working with the graph sine of x. B's 1, so 1x, 0, and then 1, 0, negative 1, and back to 0. Oh, I wrote that in the wrong spot. Those should be y values. Our x values should be our increments. Pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. You can write those out as reduced, or you can wait to reduce them until you put them on your graph. But on your graph, they should definitely be reduced. So on our graph here, we're going to plot out our sine. We're going to look at our scale just so we know where we can put our values. Looking that we're going to translate up 3 and we're going to do some stretching, I know that I've got to go by a value of 1. You're always safe if you pick 1, but it's nice to spread it out if you can. So this is a sine graph. So we go up to 1, to 0, to negative 1, back to 0. So that's y equals sine of x. We see that there's a negative in front of our equation. So we're going to reflect this over. So y equals negative sine of x. We see that there's a 2 sitting in front of the sine. The amplitude is 2, so we're going to come down twice as far and go up twice as far. Y equals negative 2 sine of x. Now there's going to be a translation. Our translation is going to move pi over 2 to the left and then 3 up. Then we can trace that out. Try to really curve your graph through those so it doesn't look like V shapes. We have our midline that you want to be sure to draw through here. Y equals 3. And our equation is negative 2 sine parenthesis x minus, it's actually a plus, pi over 2 plus 3. Our next graph, we're looking at an A value of negative 2, which gives us an amplitude of 2, a B value of 3, there's no parentheses, and our K value is negative 1. So I'm expecting the midline to be at our K value, which is negative 1. The period is 2 pi divided by B, so 2 pi divided by 3. So the increments are going to be the period divided by 4, which is 2 pi divided by 3 divided by 4. We can put that over 1. So we're going to times by the reciprocal. Gives us 2 pi over 8, actually over 12, which reduces to pi over 6. So when we have pi over 6 as an increment, that's the amounts that our x values are going to change. So at our table, as we try to graph y equals sine of 3x, we're going to use these increments of pi over 6, 2 pi over 6, 3 pi over 6, and 4 pi over 6. Sine graph typically would go 0, 1, 0, negative 1, 0. So here we have an A value of negative 2, and then we're going to translate one more. So it looks like to me that we'll be able to handle a different scale, go down to 3, working by 2's. So our sine starts out at 0, makes the climb. We have pi over 6. This reduces to pi over 3. This one reduces to pi over 2. And this guy reduces to 2 pi over 3. So y equals sine of 3x. We have a negative, so it gets reflected. Y equals negative sine of 3x. We're going to get stretched by 2, by a multiple of 2. So y equals negative 2 sine of 3x. And then we translate this 1 unit down. So we're now going to have a midline at y equals negative 1, and our equation is y equals negative 2 sine of 3x minus 1. Our final graph, we have an A value of negative 1, so the amplitude is just 1. The B value, there's no number between the x and the cosine, so that's 1. The H value is inside the parentheses. and the k value's on the outside, so I know that that's going to be my midline. So my period is 2 pi divided by b. 2 pi divided by 1 is just 2 pi. So the increment will be 2 pi divided by 4, which is pi over 2. That is your typical scale. So over at our table, where we're trying to use cosine of x, we're going to use this as our scale, pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Cosine typically starts out at 1. Our scale here can go by 2's. So we're doing cosine with pi over 2, pi, 3 pi over 2, and 2 pi. Remember, this last box, or at the edge of at the end of the cycle, the end of the period, is supposed to be that 2 pi value. So y equals cosine of x. Then we'll have a reflection. To get y equals negative cosine of x. We'd have a stretch if possible, but in this case we don't have a stretch. We're just going to translate it. So our translation is going to be pi to the right and 2 down. So pi to the right is 2 full units to the right, 2 increments to the right, and then 2 values to the right. So we'll have this midline at y equals negative 2. Have your cosine graph draw right through. So this equation is negative cosine, so it's upside down, translated pi to the right and 2 down. Last two questions we're going to do is talk about writing an equation. We know we're going to write a sine function that has an amplitude of 4 and a period of 6. If it's an amplitude of 4, we know our a value is 4. It could be negative 4. That would still give you an amplitude of 4. But typically, if the amplitude is 4, we're going to write it just as a positive, whichever though. The period equals 6. Well, we know that to calculate period, we use 2 pi divided by b. The b value is what we need for the equation. So I'm going to have to cross multiply to get 2 pi equals 6b. Divide by the 6 to get pi over 3 to equal b. We can reduce the 2 and the 6. So my equation is going to be y equals my a value, my b value is pi over 3, x, and there's no hint of a translation. For our last one, we're going to write a cosine for a graph that has an amplitude of 1/3 and a period of 2. We're going to reflect this one in the line y equals -1. Now that could actually mean a couple different things. I'm just going to focus on it as being reflected, so our a value is going to be -1/3, and we're going to call this our midline. Rather than physically reflecting the whole thing over that line and making it land somewhere else, we're going to put our midline at y equals -1. So we're going to get y equals -1/3 cosine. Our amplitude is 2, so if our amplitude is 2, we got 2 pi divided by b equals 2. So 2 pi equals 2b divided by 2, and pi has to equal the b. So in our equation, we're going to have pi x, and we're going to translate down 1. There's no note of a horizontal translation.